welcome back to my channel. So today we're gonna solve a problem called climbing stair. So this is a standard problem of the dynamic programming. The problem is straightforward. You are climbing a stair and you take n step to reach to the top. So basically there's n stair. Each time you can either climb 1 or 2 steps. So the problem asks you how many distinct ways you can climb to the top. Imagine if you have n equals n, meaning that you have 2 stairs, you can do 1 step and then the 1 plus 1 step, or you can do 2 steps. So there's 2 ways to climb to the top. So let's dive in how to solve this problem. Alright, so now we are at a problem. Let's say we have a stair of 4, right, which is n equal 4. So there's one way you can get to 4. So you can take 1 step here to the 1 step here to 2, 1 step here to 3, and 1 step here to 4. So we count as 1, right? So there's another way we can do it. So from 0 right here, we can do 1 step to 2. Oh, sorry, 2 step to 2, 2 step to 4. So that is 2 ways already, right? Or we can do it this way. We can do 1 step here, 2 step, and then 1 step. So three way, right? From this, you know that this little guy right here, he have 2 choice. He can either choose to do 1 step, or he can choose 2 step, right? That's basic. What if he is right here, right? And he choose 2 step, meaning that he out of bounds. So we not gonna go that way. It's gonna be our decision tree. We have 2 choice, right? So 2 choice. This is from 0. We have 2 choice. We can choose between 1, right? Or we can choose between 1 and 2. This is 1 step. This is 2 step. From 1 here, we can either choose 2 or 3, right? From 2 here, we can either choose 3 or 4. From 4 here, this is our result. We reach to the end, but we're gonna talk about that later. From 3, we can either choose 4, or we have a 5. 5 in here is meaning that we are, out of bounds. So basically, we're not gonna choose 5. This one is gonna be our base case. Also 4 right here, we found 4. We're gonna return back, but long story short. So in here we have 4, right? We're gonna return 1. So it means that we found one way to reach to 4, which is jump it every single time, right? This is not gonna return back 0, so the total of this is 1, right? Because we return 1 back to 2. From here we found another way. We jump from 0 to 1, right? And then 1 to 2, and then 2 to 4. So we have another way here. So from here we return 2 step, right? Let me draw it out properly. And then from here, from this little 3 right here, we can do either 4 or 5. Again, 5 is out of bounds. We can only take 4. So this is another way. So we return back here. So from this, right side of the decision tree, we have 3 steps already. So the same thing with the 2 right here. So we can either choose 3, 4, and from here 4, 5, and we don't choose 5, right? We don't choose 5. We only take 4, so we have 1 right here. We return 1. From this 4, we have another 1, and so we return 2 right here. So from this 2, we have 5. So in total, there is 5 ways to reach to 4, okay? And the way you're gonna write your code with the decision tree is always gonna be recursive. So let me jump right into the coding part for you. We're gonna do that the 2 choice. So I'm gonna do recursive. Def DFS. I'm always gonna call it def DFS. We have our I, or you can call it current, it doesn't matter. I just call it I. So our first base case, when the guy is out of bound, when we are at 4, but the guy jump out of that, the guy goes to 5. We don't want that. So if the I is greater than n right here is 4, let's for example, so what we're gonna do, we return 0, meaning that there's no way to get to, to the top. There's another base case is when I equal to n, meaning that we reach 4, right? So I return 1. That return 1 in there, meaning that we found a way to get to 4. Just like that. And I believe in here we just need to return DFS I plus 1 plus, because I plus right there, just to I plus 2, just like that. And then in here I'm just gonna return my DFS like so. All right, and let's see how it's worked. So right here looks like it's worked properly. N equals 4 right here, and the output is 5 as expected. But this part can be a little bit optimized, and let me show you how to optimize that. We're gonna solve the optimized version of it. Let's say we have this 2 decision, right? The time complexity of it is gonna be going exponential. I believe it's gonna be 2n like that, because every single decision we have another 2 decision, right? So this is a little bit big, and we have to find some way to optimize it. Okay, so let's say I am at 2 right here, right? I reached to 4, so I return 1 in here. Let me just change the color quickly. So 1 in here, and then this one is 0, so we have 1 in here, right? It's just simple. I have another 4, so I hit 1. So basically these two, this 2 right here, it have 2 ways, from this one and from this one, right? Okay, so if we find another 2 in this decision tree, we know exactly that, okay, from these 2 I'm gonna have the same 2 ways from that. Let's find it out. So in here I have 4, return 1, this is 0, 1, another 1, because I have 4 here, so the 1 again, 2, right? So why don't we catch it? We can't catch, so why don't we store this result in a kind of hash map? Let's say I have, whenever I see 2, I know exactly that I'm gonna have 2 ways, right? Same thing with the 3 right here. Whenever I see there's 3, I know exactly that it's gonna return only 1. So why don't I just store 3 right here and put 1, right? So later on, just saying when this my little one right here find out, oh, at 3 right here, oh, I know exactly it's gonna be 1. I don't have to go down to this path to calculate the 4 or even find the 5. I know exactly it's gonna be always 1, right? So same thing with 2. So with 2 again, 3 and 5, simply like that. So let's modify the code that we just have and see what happened. Let me just add a catch into that. It's gonna be a hash map. As I draw out, it's definitely a hash map, so I'm just gonna use the hash map. So in here is when I return DFS1 and DFS2, right? So instead of returning that, I'm just gonna add that result to the catch. So here, and return the catch, right? Return catch. All right, it just store in the cache and return it. Super easy. So right now what we're gonna do is we just simply add a check. So if in that cache we have that in the cache, we just return the cache. All right, super simple like that. So that's it. That's only it. So this I believe that reduced the time complexity to O of n, and the space complexity is gonna be O of n too. Yep, that is this. We call this method top down. Again, this is the top down solution. I will just run the code quickly to see what happened. Yep, as it is, pretty quickly. I know. Yep. So now we're gonna move on to the next one. For the next part, I'm just gonna go through the bottom up solution. In the actual interview, if you can come up with the top down solution, it's gonna be good already. So this one is an optional. So yeah, I just gonna show you guys how I do it. And here we go. So in the solution right here, I just add a few lines of code, but it just print out my catch. And you can see below here we have our catch printout, and definitely you can see a sequence. Okay, so I will draw that sequence out. All right, friends, from 3 right here, you know, we can either get to 4 or we get to 5, right? And we know that 4 they have 2 ways, and 5 we have 1. So basically from 3 right here, we know exactly we have 3 ways to get either to the 6 point, right? So it's basically 2 plus 1. So we have 3 right here. Let's say we have 2 right here, right? We are at this position 2. We can either get to 3 or we get to 4. And we know that when we are at 3, we have 3 ways, and when we are at 4, we have 2 ways, right? So it's basically just at this position 2, we have 5 ways to get to 6. And we work our way up like that. From 1 here, same thing. It's gonna be, we're gonna have like from here to here, or from here to, from 1 to 2 or from 1 to 3. So basically it's gonna be 5 plus 3. So it's gonna be 8. Again, when we are here, we can either get to 1 or to 2. It's gonna be 8 plus 5. It's gonna be 13 right there. So this is the sequence, and if you recognize, the sequence is look like it's either the next number, let's say 3 right here, is gonna be equal to 2 plus 1. 5 right here is gonna be 5 right here is equal to the two previous sum. So 3 to the 8 right here get from 5, 3. The 13 right here gets from 8 and 5. All right, that okay. So let's say to code it up, I would just have, you know, an I pointer and the previous node. You know, to previous node will be equal 0, then I pointer is 1, and then I just go through an array until I reach 0. All right, let's get started. So as I say, I have a current node and the previous node, right? The current node I will put at 1, and the previous node I put at 0. I'm just gonna go through every single items. So for in range n, right? So in the drawing, I go backwards, but you know, if I do range n and it go from the left to right, from 0 to 6, it doesn't matter. It's just going to backward because I'm just trying to create the sequence, right? So in here, it's just basically a temporary variable. Is just to hold my curve, and maybe the current's gonna be equal to, it's gonna be itself plus the previous number. The previous number is gonna be equal to current. So basically just that, and then in the end we return current. That's it. So that is just how it's go. Yeah, and then let's try to run it to see if it's worked as expected. So yep, that is it for the code. If you like the solution, just hit the like button, subscribe, help the channel a lot, and see you guys again in the next video. Thank you.